Welcome, everyone. Today, we're going to be talking about the fundamentals of linear content creation. And I want to thank Epic Games for this opportunity to do so today. I'm a senior project specialist with Epic Games. And I want to just ask the audience really quick, how many of you are in the film and animation world? Anyone else? Anyone from games? How about automotive, product design? Got a couple. All right, just getting a feel of the audience. Today we're definitely gonna be talking about the fundamentals. But first, a little bit about myself. I have a 22-year film career. I started at a little company called Industrial Light and Magic as a technical assistant, checking tapes and watching renders overnight. Worked my way up to become a look dev, lighting, and compositor. I eventually found my way to Sony Pictures ImageWorks, and there I led teams of artists as a look dev and lighting lead, as well as a CG supervisor. More recently, though, I became intrigued with real-time and real-time workflows, and especially virtual production. So much so that I decided to join Epic Games. And since joining, I've had the great opportunity to help other artists and studios transition to real time, as well as chart out the future of Unreal. So here's some work that's been done in Unreal. It is all been done with virtual production techniques and real-time workflows. We'll just let this play so you guys can enjoy it. Some of you in the audience may have worked on some of these, potentially. All right. So my aim today is to introduce those who are coming from a film and animation background, who may not know a lot about the engine, or those who may know a lot about the engine but have no idea about the filmmaking process in the engine. Today we'll be covering some of the what, how, and why. Some of the why, what, and how of using real-time workflows in production of linear content. All the concepts I'm going to be talking about today are actually in a guide that's online called the Technical Guide to Linear Content Creation. And you'll have to bear with me until the end of my presentation, where I'll give you some more information on where to access that guide, as well as some other links and resources. But first, I want to lead our discussion with the iron triangle. You may not know the iron triangle by name, but you know the concept. Anyone in production knows this pretty well. Basically, the concept is you can create something or work on a project and be good and fast, but it will be of poor quality. You can be fast and cheap, but it will not be very good. And you can be good and cheap, but it will not be very fast to complete. So let's face it, in visual effects and animation, choices have to be made daily on where to put resources. And oftentimes, we have to choose between these. And the saying goes, you can only pick two. And that seems true in most cases. If the production's in real trouble, you're lucky to get one. So today, I propose that with real-time workflows and virtual production techniques, we can potentially turn this paradigm on its head. Unreal Engine, along with a host of other supporting tools in Epic Games ecosystem, opens the door to new and exciting possibilities. In combination, these tools can attack all three simultaneously, and the things that once were impossible are possible. And how I like to say it is, if the things that were unrealistic can be unreal now. So, but regardless of the poor marketing pun, our ultimate goal here at Epic Games is to attack all three areas so that it has a major impact on content creation and storytelling, which by empowering teams, they can have new heights of creativity and at a film quality level without any compromises. So let's see how this is done. So here I have two diagrams. One is a traditional offline pipeline. The other is a real-time pipeline. The traditional production, using a traditional offline pipeline, uses an assembly line approach. So all the tasks are kind of handled linearly on a shot and performed sequentially. Whereas we can see with the real-time workflow, it's like a little bit more holistic. Departments can work simultaneously or in parallel, and they work closer together. And it's very much a nonlinear workflow. Typically in a traditional pipeline, directors who are seeking to get their creative vision realized have to do a lot of pre-planning up front because it's really difficult to make changes later on. It's like a snowball effect, essentially. Any last minute changes in the production are really difficult to achieve. And unfortunately for the directors, their vision isn't really realized until towards the end of the production. But with real-time workflows, directors can see things immediately, and the workflow gets kind of turned on its head. Things can be rendered in real time, and this enables rapid iteration and saves huge amounts of turnaround time. And what's even better, in a real-time workflow, the first draft of the project that's coming out of story development could be, the first draft of the story can be coming right out of story development. And the teams can start working on it immediately and work on it continually through the entire production, right up until the end. Sorry about that. Each department and everyone on the team has a complete view of the entire project, and they can scrub through it, see there are changes in the cut, and it makes a great opportunity for everyone to contribute more to the creative process and realize the director's vision. Real-time workflows can fundamentally change how we approach production from start to finish as well. Here are some of the advantages of real-time workflows. So the first one is speed. Because we can iterate quicker and faster, we can achieve more in a short period of time. And when we iterate, obviously, the more iterations you have, the more possibilities of having creative ideas that come to you. And all those new creative ideas help improve the story. There's visual fidelity. More recently, game engines have been capable of doing full film quality rendering. And this has allowed us to do things and achieve things early on in production visually, where you can see what the final product will be before we're even close to finishing production. And then collaboration. These by which teams can get together in a 3D space and collaborate makes it possible to find new opportunities for creativity. Many teams have remarked that when working in real-time workflows, that they liken it to almost being on a film set. In the old days, where everyone is working together in the same environment, ideas are being shot off here and there, and everyone's working toward the final goal of realizing the director's vision. Some of the advantages that come with that are more opportunities for creativity, more opportunities for visualization, more iterations, faster turnaround times, better storytelling, and as I mentioned, you can also get closer to the director's vision. And as a bonus, after you complete your project, because you've built all your assets in a real game engine, it opens up other opportunities in other mediums, like games, XR experiences, live performances, the list goes on and on. So now we're going to talk a little bit about pipeline development. And I'll just say this, having access to source code when you're trying to develop a new pipeline is essential. And I mean, look at her, look how stressed she is. I don't think she has any source code. So Epic Games, because Epic Games has released the source code for the engine, and it is freely available to both use and modify. And on top of just the engine itself, the plugins and also some of the related tools are also available as source code. All the current releases, as well as all the development branches, are available on GitHub. As well, if you're a studio, you can also gain access to Epic's Perforce servers. And then the binaries for the engine can be compiled by yourself, or you can download them. And they're available on Windows, Mac OS, and recently Linux. So those of you who have Linux machines, the engine has recently been released on it. And then this brings us to a related tool, which is called Universal Game Sync. And this tool kind of simplifies the synchronization process, as well as the compiling. It kind of does all the legwork for you, so you don't have to really know how to use Perforce, which if you've ever tried to use it, it's a little complicated. And then the other neat thing you can use it for internally is if you're making modifications to the engine or you're wanting to distribute binaries of the engine to those in your team, you can use Universal Game Sync to do so internally inside your organization. And then this is the next big thing when we come to talk about the pipeline. Obviously, we need to be able to integrate it into our systems. And Unreal supports a myriad of scripting and programming languages, as well as providing some robust APIs to interface with the engine and customize it, as well as improve or automate it. So we have blueprints. So blueprints are essentially a visual programming system that's somewhat artist-friendly. I would say it takes a little time to learn, but once you learn it, it actually makes it really quick to build tools, drive rigs, and animation. And you can anything you can do with C++, you can do in blueprints. And then Python is essential in our modern pipelines. Anyone in film or animation production knows that Python is kind of the glue of all our systems. So Unreal ships with Python 3.9, has a full Python API, and it also can support PyQt applications. And then there's HTTP and JSON. So those are to support web-based applications, as well as be able to interface with some REST APIs. And then C++. Obviously, the game engine is written in C++, and because the source code isn't there, you can extend the engine as much as you want. And then the last two, editor utility widgets are specialized blueprints for creating UIs. And then one step above that is Slate, which is actually what the engine's UI is designed in. It's a collection of widgets and tools for creating UIs and applications. So here is a quick demonstration of our next topic, which is LiveLink. LiveLink provides a common interface for streaming and consuming motion data. And those data sources can be external. It actually uses internet protocols to communicate, and it allows us to use our favorite animation tools so we can interface it with Maya like we see here, or other applications like Motion Builder. It also allows us to stream in mocap data and virtual cameras. And it can consume pretty much any kind of motion data. And the best part is it also supports timecode. So if you've got multiple data streams, you can use timecode to sync those data streams. And on top of that, LiveLink is also extensible. So you can extend it to the needs of your production. So if you've got specific hardware requirements or any of those type of things, you can extend it. And also leveraging on the back of LiveLink are two applications that you should be aware of if you're not already. And that's LiveLink Virtual Camera and LiveLink Face. LiveLink Virtual Camera allows you to do cinematic virtual cameras from your phone, and LiveLink Face lets you do facial capture. And they come in really handy when you're doing virtual production. And this brings us to multi-user collaboration. On the right there is a screenshot of the interface. That's just the interface to kind of interface between the different users. But multi-user is one of the most powerful and truly exciting additions to Unreal. It unlocks the joy of collaborative filmmaking with unimaginable creativity. So multi-user makes it possible for you to get your team together. You can have set decorators, lighters, camera operators, actors who are in motion capture suits, your DPs and the director all together in a session, working together to create whatever the director's vision is. Key decisions can be made on the spot, changes can be made on the spot, and then immediately played in the cut to see how those change fall in line with the cut. And then when you use multi-user workflows for your client, internal, and departmental reviews, you can save time and money because you're not having to iterate and wait for a review to take care of issues. So we're going to see a little bit of this in practice. So here, there are a couple of artists collaborating in a single multi-user session to build a few shots in a sequence. And in this case, they're all in the same room. However, they could have a connection with someone who's outside of the room from anywhere place in the world, as long as they have a good internet connection. They have two cameras that they're shooting with, or two virtual cameras, and they're collaborating together in real time and in parallel. Here, they're doing some set decorating. And in the meantime, the director's giving directions to the actors in the cameras. And the actor's actually saying, what's up with all the set decorating? And because of this, the entire team is collaborating in the shot design. And as they finish, they can finish it and do the final take, as we see here as it wraps up. Here at the end. And just like on any set, there's a lot of standing around. All right. As I wrap up the topic of pipeline, there's one thing I want to talk about that's really important. Many teams get too confident when they jump into Unreal and don't really test their pipelines before starting productions. And sometimes this can really jeopardize a project. So that could all be avoided if they just had done some proper testing early on. So the best way to avoid that is called what I call vertical slice testing. This is where we test the pipeline from beginning to end through all the workflows, through all the departments and all the particular scenarios, and just make sure that our expectations meet what we're actually getting out of the engine. And to do this, we typically pick 1 or 2 test shots from our production, or you can create a custom shot that might run everything through all the scenarios. Besides this, we also need to be aware of certain situations that might be hardware intensive. So if you've got large crowds, lots of characters with hair or fur, you want to run the engine through its paces and see if you have any bottlenecks or made any bad assumptions, and you want to fix those. And if you do it early in this stage, then it's fixable. But if you do it in mid-production, it makes it very difficult. All right, so now we're going to talk a little bit about some of the things that are unique to virtual production and real-time concepts in pre-production. One is the formation of a department called the virtual art department. So there isn't really anything like this in regular linear content creation. So a VAD is a multidisciplinary team whose origins come from the onset needs of virtual production. And I would liken them to kind of like the elite team that you call in to solve all your problems. The VAD team usually consists of very seasoned real-time artists, and they can not only support the production team on set, but later on they can support the entire production all the way through to the end. The roles of a VAD team can vary from production to production, as well as during the production. And for example, in pre-production, a VAD team can support the VizDev department, so they can work with production designers, art directors, and concept artists to help visualize the project. They can build sets and CG assets, ingest data such as LiDAR and mocap, as well as motion data. And then after like a session on the set, they can do some post-viz to improve to make the visualization of the shot even better. And then in post-production, the VAD team can complement the rest of the production team by supporting the team with real-time technical expertise and know-how, redesign and reimagine shots as ideas come up. Whoops. Didn't mean to do that, sorry. And they can also take shots all the way to final and complement or enhance the output of the entire team. So, why not start pre-production off right and go right into story development right in the engine? So one of the lesser known and cool things about Unreal is storyboarding. A company called Praxanos, working through an Epic Games Mega Grant, created 2 plugins that you can download and use for free from the marketplace. One is called EPOS, which sounds funny, but even the real name is even crazier. It's the Extended Production of Storyboard. That's what it stands for. Which is a 2D storyboard animatic plugin. And the other is called Iliad, which is a painting tool that's built into the engine and uses blueprint brushes that are customizable. In combination, these 2 plugins make it a simple and intuitive workflow for 2D storyboard artists. And it allows them to use and leverage 3D assets in their process. Here we have a CG environment of the gym, which is being used as a backdrop to the story. And using CG cameras, the storyboard artist has set up cameras and has then painted storyboard frames of the characters in action. The storyboards live on an image planes relative to the camera, and you can orbit around those, and you can see they're actually just planes in the environment. But a storyboard artist doesn't necessarily have to use a 3D environment. They can just paint full storyboards if they want to, right in the engine and right in sequencer. And then you can take that and throw that right into production and start working on your shots. So now we've gotten through that. I couldn't cover everything in pre-production, but we're going to go ahead and move on and talk about production. And this is one of the biggest topics about real time, and that is optimization. So let's talk about that first. This is where I give the legal disclaimer of my presentation. So I have to state the obvious. To be able to render stuff in real time, things have to be performant. So it's best to go in with our eyes wide open and know what to look out for when we start our productions. For real-time workflows, optimization needs to begin early, and usually issues arise as an aggregate of poor decisions early on. And at first glance, it may not seem critical for film and television to worry about optimizations in the engine. However, when it comes to interactivity and quick turnaround times, having optimized scenes is very critical. As with any other DCC or rendering pipeline, there are certain things that we should avoid, as well as things that are supposed to be used sparingly. Because performance does matter in real time, we should become educated. Having your teams become educated about optimization techniques and workflows in the engine. You should avoid assumptions. Do not assume that certain tried and true techniques that have worked for you in the past in a traditional pipeline will work for you in real time. It may seem like it's working in the first stages, but then when it gets to scale, when it really matters, it will all come back to frustrate you and haunt you. You should profile frequently. We need to periodically profile our projects and look for performance bottlenecks and troubles. Start early and do it frequently. We even recommend having a point person on the team who's periodically checking for those problems in the engine. And then lastly, be current with future changes and updates. The engine is constantly changing and improving, and workflows that were once tried and true and performant in the past may not be as good as the new upcoming workflows. A good example of this is the recently released Nanite and Lumen in UE5, which replace older systems and are much more performant than the older systems. All right, so now I've got the disclaimers over with. We're going to talk about world building. So every story needs its world. And like any artistic endeavor, we start with a blank canvas. This is why it's important for us to fill that canvas as quickly as possible. And we do this with, painting the canvas with broad strokes. At this stage, we want to keep things simple. And stand-ins are just as useful as final assets. This is where we can borrow something from the game industry called gray boxing. To help with gray boxing, there's a bunch of fairly robust modeling tools in Unreal Engine. There's binary space partitioning tools, which are just a fancy name for your basic polygonal geometry that allows you to do booleans. And then there's the new modeling tools in UE5, which are quite robust, even though it's still experimental. There's quite a bit you can do with those tools. And then lastly, there's also geometry scripting, which is a node-based procedural geometry scripting system that allows us to build tools that build geometries procedurally or dynamically. And then we can obviously take gray boxing a whole step further by using pre-built assets. And so we've got, in Epic Games' ecosystem, we've got Quixel Megascans, which is the world's largest library of photoreal film quality assets. Quixel is even built right into UE5. So you can literally drag assets right out of Quixel Bridge right into the engine, and it will download it for you and put it in your scene. There's also the Epic Games Marketplace, which contains a whole host of pre-built assets, sets, environments, effects elements, characters, rigs, scripts, and tools from Epic Games and also from the community. And then if you can't find what you need there, there's also Sketchfab and ArtStation, which have millions of additional assets that you can download for free or purchase. In addition, there's a whole host of asset generating tools as well. So here are 4 of those tools. MetaHumans and Mesh to MetaHumans, which is new, can give you animatable photoreal humans to put into your projects. Reality capture and reality scan to create digital versions of your props. So if you've got a chair or something, you have your favorite Barker lounger, you can scan that and take it into the engine using photogrammetry. And the neat thing about it is, like with reality scan, is you can use the phone in your pocket to do so. And then there's Quixel Mixer, which is an all-in-one surfacing and 3D texturing painting tool, which we feel is the fastest high-quality texture tool out there that we feel. Unfortunately, I can't talk much further about these today, but I just wanted to point them out so you can check them out on your own. All right, so now that we have a world, we need to be able to animate our characters in them. So one of the things that Epic has been dedicated to is improving the rigging and animation in the engine. And with the recent release of UE 5 and 5.1, you'll see there's quite a bit of improvement over past versions of the engine. We have Control Rig. Control Rig is Unreal's node-based rigging system designed to provide riggers and animators with tools to create flexible, dynamic, and procedural characters with artist-friendly interfaces. Control Rig also has a full-body IK tool set, and we can retarget animations or transfer those animations between characters of different proportions or different skeletons, allowing us to repurpose our existing animations onto other characters. We can animate in Sequencer with a whole new host of new animation authoring tools, which include a pose library, a tween tool, a snapper tool, space switching for Control Rig, temporary pivots, and editable motion trails. We can bake animations for better performance, and we can even layer and blend animations to simplify the animation process. There are morph targets and blend shapes that can be driven by Control Rig and Sequencer, and this eliminates the need to round trip or having to cache geometry to geometry caches. And then lastly, we have machine learning deformers, which use Unreal's neural network interface, as well as a deformer graph system so that everything stays on the GPU. And the plugin also, basically allows you to recreate high dynamic deformations between the engine and other DCCs. And there's even a plugin from Maya that allows you to create the data sets to feed into the machine learning algorithm. All right. This brings us to Sequencer. Sequencer is where the magic happens. It is the storytelling and editorial hub of the engine. The Sequencer is a powerful multi-track editor used for creating and previewing cinematic sequences. At the core of Sequencer are tracks. This is where you can add anything to the shot or a sequence. But unlike a nonlinear editor, you can add stuff way beyond just your typical media and audio tracks. You can add anything you want to animate in 3D on a timeline, you can add in Sequencer. And then at the heart of Sequencer are level sequences. Level sequences allow us to add tracks, create keyframes, and manipulate characters, objects, and cameras. They can even contain other level sequences. This is how edits can be composed into shots and shots composed into sequences, and sequences composed into full cinematics. So here I provided a QR code that will take you to a project that's called Slay. Slay was a Epic Games Mega Grant project done by Mold 3D, which is free to download and use off the Epic Games Marketplace. It showcases the power and flexibility of Sequencer and the proper use of using level sequences within Sequencer. And as I mentioned, level sequences can contain other level sequences. So we can use this to our advantage. So we can also use level sequences and layer them. We call these subscenes or edit layers. And they can be non-destructive. And this allows us to build upon and modify an existing scene without having permanent changes to that scene. If you're familiar with USD and edit layers in USD, it's a very similar concept. One of the things with subscenes, because they are non-destructive, we can use them to contain departmental changes to our shots, as well as be able to version control and manage those separately on a per department basis. In this example, I have a single shot with a few tracks that have subscenes for each department, one for animation, VFX, camera, lighting, and meta sounds. And each subscene represents the work being done by the department. And then I've expanded out 3 of those to show that those also contain level sequences. And those are broken up even further. So what can you do with that? Well, you can break out your tasks in your department on an artist or task basis using level sequences. And because these are non-destructive, there's no worry. You can mute these tracks and see what it's doing to the overall scene. And then you can also change the priorities if you need to. But you can go as granular as you want with this. And so it really is quite flexible. Now we're going to talk a little bit about editorial. One of the most common questions we get when it comes to the engine, and more specifically Sequencer, is how to interfaces with editorial. Which makes sense, right? We can approach editorial in the engine in a couple ways. So first, we can do editorial directly in the engine. Sequencer is a non-linear type editor. Being able to do editorial directly in the engine is quite significant because it allows us to develop our story directly in the engine, as I showed you with the storyboarding. It can compress story development, previs, and rough layout all together. And it also makes it a little bit easier to do late cut or late changes to the cut when you have a new creative direction that you're going with. However, if you still choose to use your typical nonlinear editor, Epic has tried to make that a little bit easier for round tripping. So we've got support for EDLs, Final Cut Pro, and Open Timeline IO to make our turnarounds and those type of things a little bit easier. All right, so this brings us to some new developments that come with Unreal 5 that I think have a real impact on the industry, and especially for linear content. They are Nanite, Lumen, and the Path Tracer. So we're first going to talk a little bit about Nanite. In the past, modeling requirements for real time were not as stringent were more stringent than they are today. With Nanite, we have a little bit more flexibility, and we can add film quality models and assets to the engine. This opens up a whole new world of possibilities. When we talk about Nanite, we're actually talking about virtualized geometry, which is very similar to virtualized textures. And what that means is that Nanite only loads the geometry that it needs to load from the view of the camera. We can now use film quality meshes and with higher triangle counts and object counts and which also have higher geometric complexity. Nanite is also very efficient. It renders quicker and takes up less memory than the older systems it replaced. And although currently Nanite doesn't support deforming surfaces, you can make animatable characters with Nanite with static meshes. So you can parent static meshes to a skeleton. And that's actually how, if you're familiar with the Ancients, Valley of the Ancients demo, that's how the Ancient was created. Next is Lumen. Lumen is a new fully dynamic real-time ray trace global illumination and reflection system. Lumen solves the indirect diffuse problem that we've had in the past inside of a game engine, where we've traditionally have had to bake light maps. In this example, we see light bouncing diffusely off the surfaces. And as it does so, the light picks up color. We call this light bleed. And as we move meshes around, you'll notice that it also has indirect shadows. So we're getting a good approximation of actual global illumination in a scene. And then lastly, we're going to talk about the path tracer. The path tracer can be used for final pixel or as a ground truth comparison for a lumen. The path tracer produces output that's typically not seen in a game engine and only seen in offline renderers. It gives us physically correct and compromise-free global illumination, physically correct refraction, feature-complete materials, as well as super-sampled anti-aliasing. Many film and animation projects use the path tracer for their final pixel. And I just want to note, you guys are getting a little sneak peek of the movie render queue as well in some of these demonstrations. All right. Before we talk about rendering, I want to talk about the color pipeline. So the color pipeline is critical for virtual production as well as for visual effects and animation. And so it's really important that we have a robust pipeline. Unreal Engine's color pipeline uses industry standard open color IO and has full support of the ASUS Academy color encoding system. Here's just some of the features that are available in Unreal's color pipeline. 2 at the bottom, the working color space and the per texture color space and encoding overrides are new to Unreal 5. And what they do is allows us to create a project-wide color space. For example, we can use ASUS CG as our underlying color space in the engine. And then on top of that, we can change the color space of our incoming textures depending on what our color space is without having to go outside the engine and do that turnaround outside the engine. So it can be done directly in the engine. So this brings us to movie render queue. So this is where actually we're creating creating imagery out of the engine. MRQ is Unreal Engine's image sequence and movie rendering solution. And it's built for rendering high quality imagery. It's extensible and it can be integrated into our production pipelines. Besides the features listed on the slide, which are quite a few, Movie Render Queue supports some additional features for high quality renders. Lastly, we can run and manage multiple jobs with it in a manageable queue. And it can also be extended to work with other existing queuing systems, such as Deadline. So I'm going to quickly just look at some of the features. There's so many, I can't cover them all, but there's a few. We can manage multiple shots or sequences, and we can select which ones we want to render and not render at any given time. MRQ supports rendering post-process materials, such as world depth, world position, and motion vectors, and there's many more. And then it also supports object IDs. So object IDs are also known as cryptomat. Here we see a nuke, a render pass of the object ID pass. And then here we're going to use a multi-channel EXR and output those post-process materials into layers in the EXR. And then lastly, MRQ supports Apple ProRes and Avid DNX codecs. So if you've got special needs in terms of what type of outputs you're outputting, you have those codecs to work with. All right. So that was a lot of information that we covered today. But there are a few key takeaways that I want to share with you that I think will make your experience with the engine more successful and more enjoyable. First, embrace the engine. The old saying goes, you can't take a square peg and fit it in a round hole. With Unreal Engine, the techniques used in offline pipelines may not be optimal in a real-time workflow. So instead, embrace the capabilities on the engine, and you may find that those old crutches that you've clung on to work around problems in the old pipeline isn't needed in a real-time pipeline. Enjoy the process and the journey. Like all new adventures, there are a lot of unknowns, and when we're doing something new, it can be challenging. So there'll be challenging days and rewarding days. Take those days in stride and know that we're living at the cutting edge of a revolution in storytelling and linear content creation. Seek help online and from others in the community. While Epic Games tries our best, we try our best to give you as much information as possible and to help you both learn and solve problems. The community is available there as well. And a lot of the big problems that are difficult to solve have been solved by people on the portals and in the communities. So you just have to go out and reach out and ask the question. And then lastly, when you do something amazing, you've solved a problem with little to no documentation, or you find a neat little trick that you want to share with someone, pay it forward and give it and tell the community. The community around Unreal Engine is amazing, and we're all in it together, so let's help each other out. All right. So this is the end of my presentation, and I hope you were able to keep up with all that information. But don't worry, if you haven't, you can access the technical guide from the Epic Games developers portal. Here's the QR code. That's what it looks like. And the one thing I recommend is to go and check it periodically, because we do update it and try and keep it current with the latest developments of the engine, as well as the best workflows. So, there's lots of information there, and if there's something that you can't find on there and you wish you had more information about, you can feel free to contact me, and I'll try and get something put up there for you. So thanks again for your time and interest in real-time workflows, and especially the fundamentals of linear content creation. Thank you.